Hi, review questions part 1. Okay, question 1. Here we are. Lower 5th review questions 2020. Question 1, we're looking at potassium permanganate crystals dissolving, and once they've dissolved, then the dissolved ions will diffuse. Okay, they've shown it after a short time, so it hasn't fully spread, but if we left it for longer, it would spread. So the key thing here is first of all, the crystals dissolve in water. Then the next question, when you say we need to read that it's left until there's no further change. Okay, so what will happen is that purple colour will diffuse. So I've written down later this spreads. Okay, this purple colour will diffuse. So all of the liquid is purple. So a lot of people went for C, which is wrong because eventually it will all spread. Okay, the process is called diffusion. And then it says how many different atoms or how many elements are there. Well, you've got potassium, you've got manganese, and the other element you've got there is oxygen. It doesn't ask for how many different atoms there are, how many atoms there are in total. They're asking for how many different types of atom, and that means how many different elements. So question 2, relatively straightforward. Looking at those ones, we're looking at the charges. Okay, so that one's neutral, and the neutral particle must be a neutron, because we're looking at the charges here, and the location. Neutrons are found in the centre. Particle Q is also found in the centre, the nucleus, and it's positive, so that must be a proton. Positive. And the last one here is the particles that's going around the outside R, which is negative, and the negative particle, which is not in the centre, is the electron. Right, negative. Then it says name the part of the atom which is labelled S. That's the nucleus, that's the centre. Okay, it's got no electrons in it. Okay, so that must be the nucleus. Quite a few people labelled S as the shells, but there are no electrons in it, so how can it be the shells? Quite often we don't draw the structure around it because it's kind of a bit wrong. What is the atomic number of this atom? Well, it's got 5 protons, which is the atomic number, and if we look back at the periodic table, it actually tells us. Okay, then it asks here about the mass number, which is protons and neutrons, and that's 12. And I think eventually it asks us what is the actual type of element it is, and for that we need to look at the periodic table, look for the subparticle with the 5 protons. Okay, so we're looking for the atomic number of 5, which is boron. Should be relatively straightforward, but a lot of people made mistakes on that one, silly errors. Okay, I'm sure you get it, but just a silly error. So it's boron. Okay, so question 3. Okay, give the letter of the that represents noble gases. Noble gases are on the side, so the letter that it can be must be T. Element L and M are in the same group. Why are they? State why they have the same or similar chemical reactions. Okay, it's not just because they're in the same group, it's because they have the same number of outer electrons. Or the Okay. Next one, Q is 31, so what must R be? Well, R must be 33, that's 1 mark. How do we work it out? Well, as you go along, the number of protons increases by 1. That's effectively the way you do it. So 1 mark for 33, telling us what it is, and then saying that as you go along, each element from left to right, the number of protons increases by 1. So if you go 2 spaces, 31, 32, 33. Right, okay. Question 4. What's question 4? We've got to, first of all, explain what is meant by an isotope. And then we have to show why its relative atomic mass is 80. So the first thing, what is an isotope? 1 mark is atoms of the same element. Atoms of the same, that should be atoms of the same element with different numbers of neutrons. Here we are, atoms of the same element with different numbers or different mass numbers or different numbers of neutrons. But they have to be of the same element. Okay, and then the next one we have to show by calculation that the relative atomic mass is 80, and we've got to show the calculation for it. And what you do is you take the abundance, so 50 over 100, times by the isotopic mass, plus the abundance of the next isotope, which is 50 over 100, times by the isotopic mass. And if you work that out, that should give you 80. Right, here we've got a diagram of a molecule of halon 1301. Okay, so if we look at them, they're all non-metals. And the type of bonding that exists between non-metals is covalent bonding. Covalent bonding involves sharing of pairs of electrons between nuclei. So that's something that we need to show in our diagram. It's not ionic bonding because they are all non-metals. If you don't even remember, you'd need to look back at the periodic table. Okay, so first of all, I've just drawn here carbon with 4 electrons in its outer shell. Then I've drawn the overlap, okay, of boron, fluorine, fluorine, fluorine. And in the overlap, there must be a pair of electrons because each is a covalent bond, because we're drawing a dot and cross diagram. So showing 4 covalent bonds is 1 mark. Okay, so dot cross, dot cross, dot cross, dot cross in the overlap between outer orbitals is 1 mark. And getting all the other electrons correct, so putting the remaining 6 electrons on each of the fluorine and the 6 electrons on the bromine gives us the other mark. So that's how we get the 2 marks there. Pretty standard question. So this one is a plotting points. Oops, I've just missed the page. Let's go back up. So I need to plot these points using the data above. I've got to plot them as neatly as possible. That's 1 mark. So by plotting a graph that looks like this, it's laborious, but it's a fairly standard sort of question. Got to try and get them right. As a general rule, you've got to get within plus or minus 1 square at this level, but at GCSE you need to be spot on. So 0, 0 is one of them, and I'm starting to plot them as they go up. Now each square is worth 2 going up and 1 going across. So just get these right. Oh, I've just done it again. So plot it. That's only 2 points so far. So keep on plotting them. That's 3, 4. Now remember, this is a rate graph, so the reaction is greatest at the beginning, so it's really steep. But as the chemicals get used up, the rate drops down because the concentration of the reactants falls. So there are fewer collisions per unit time, fewer successful collisions per unit time. So we can say the frequency of successful collisions drops, and so it starts flattening off until it gets to 84, and they have to be fairly correctly plotted at 84. Okay, trying to use nice fine crosses or dots. Okay, and then we have to draw a half decent line of best fit. Needs to be a smooth curve. It may not be perfect, but it has to be pretty good. That's not too bad. I'll give myself a mark for that one. So there's 2 marks there. And then we have to look at these 2 examples below. One is, so there's the marks I'm just putting there. So B1, we're looking at half the amount of magnesium. So we're using half the amount of magnesium, so we're going to get half the amount of gas, because magnesium is not in excess. This is the limiting reagent. So therefore, we've got to work out what half the amount of gas is. So half of 84 is 42. So that gives us the end point. Roughly the same concentration at the beginning. Okay, oops, got a bit of a mess there, but that's kind of what you need to just draw. So that's the same rate at the beginning and half the amount, so that's 2 marks. Just not as smooth as it could be. But the two features are there. Roughly the same rate and half the amount of gas. And then you've got to label it. One of the parts of the question is you've got to label it Y. So if you don't label it, you don't get the mark. And Z, here we've got the same amount of chemicals and the same concentration and the same volume of acid, but it's at a higher temperature, so the rate is going to increase. So what that's saying is the amount of gas produced is going to be the same, but it's going to get there quicker, so the graph is going to be steeper. So you need a steeper graph that flattens off at the same, roughly the same point, 84. So we need to label that Z and Y. So the feature there is so that's 1 for the rate, 1 for the amount. Here the rate is steeper, and there the end point is the same. So that's how we marked it. Good question, I like that one. Right, here we are. Expected volume of the gas produced in the first experiment was 86. Suggests why the volume collected was less. Well, do you know what? You've lost some, basically. That would suggest that in the process, when you look at the mechanism, just by putting the bung on there, the reactions are started, so some of the gas escapes. The student uses a graduated beaker to measure the volume of dilute hydrochloric acid. Explain why it's not necessary to measure. Well, it's because the acid is in excess. So you don't need to be very accurate with it. You just need to make sure you've got the same amount and it's more than you need for the reaction. It's not the limiting factor. So very accurate volume's not needed in this case. So there's 2 marks. Okay, use the information in this equation and the particle collision theory to explain why the rate of reaction decreases during each of the experiments. Well, what's happening here is the reactants are being used up. So the surface area of the solid is decreasing, or the concentration of the acid is decreasing. So therefore, what's happening is there are fewer particles available for collision. So either one of those will have done. That's 1 mark. Therefore, there are fewer successful collisions. Another mark. But then it's important that you include the frequency or the collisions per unit time. So the number of successful collisions per unit time, or the frequency of successful collisions, decreases. So that's why the rate drops. So the first thing is about saying that the reactant, one of the reactants or both of the reactants decreases, so there's fewer particles. That's 1 mark. Then the next mark is about the fewer successful collisions. Okay, that's 1 mark. And then the final mark is to include the idea of a frequency or the number of collisions per unit time, because that's what determines the rate. It's all about how time affects it. So just trying to allocate the marks here. So here we are looking at fewer successful collisions, because it's all about collision theory. And then the last one is the lower frequency of those collisions. So that could have been in 1 or 2 sentences, but these are the key components of the sentences that we're looking for. So fewer successful collisions, as we're saying, and then it's the lower frequency or fewer or reactions per unit time. Right, and then we can allocate the marks to the various sections. First section is 1 mark, second section is 1 mark, and third section is 1 mark. Okay, well done.